So thank you everyone for joining us at 4 o'clock on a Monday afternoon, and happy International Dark Skies Week. My name is Elizabeth Stoja and I'm with the Gateway and Natural Amenity Region, or the NAR initiative. And welcome to our Dark Sky Monitoring in a Hazy Future. So this webinar is hosted by the Western Night Skies Council and is a partnership, which is a partnership between the Gateway and Natural Amenity Region Initiative and the Colorado Plateau and Basin and Range Dark Sky Cooperatives. One of the things we learned last summer is that wildfires and the smoke they produce is a regional challenge. So here in Utah, we were fortunate to have a moderate wildfire season. However, as many of you know, Oregon and California were hit particularly hard, and the smoke and haze from those fires did affect us here in Utah. We haven't thought much about how haze can impact the night sky until one of our panelists, Justina, brought it to our attention as an organization. So she highlighted how much smoke was affecting the night sky and how little anyone was talking about it. So that spurred the conversation we're hoping to have with you guys today. So we'll be monitoring the Q&A and the chat. And with that, I am going to pass it off to Justina.
All right. Hello, everyone. I hope you can see me, and welcome to this discussion that I'm really wanting to get started. And you can go ahead and advance to my first slide, if you will. So I work for Utah State Parks, and I started the Utah State Parks Dark Sky Initiative in 2015 at the request of several parks, 10 parks at the time, who wanted to pursue international dark sky status. And so I put together over the years various teams of seasonals and volunteers to help with all of the work that it takes to get a park designated as an international dark sky park, and then to carry on with programming and monitoring, et cetera, after designation is received. Do you want to go ahead to the next slide? So Utah State Parks Dark Sky Initiative is, we just talked about that, so you can go to the next one. We've gotten successfully 10 parks designated in our system between 2016 and 2021, and you can see the list there. We started off those 3 top parks. They were the pioneers for us in our system. They all started in 2015 thinking about doing this, and gave a presentation at my annual interpretive training to folks, and that's why the other parks got excited. And so we got our first parks designated in 2016, and then we were rolling along at 1 a year, and then unfortunately our leader of state parks died in 2018, and that kind of put a hitch in our going for stuff. But then we got started again in 2020, and then we rolled on and finished those applications. And so as you can see, we have 10 beautiful international dark sky parks right now. Next slide. And right now we have 5 more in process. We have submitted Gunlock. We're working out some things they want us to do on that application. And then we have these other 4 that are in various states of the process right now. Okay, next slide. So, we started taking readings in 2015, 2016, that season. And then when we returned hard hitting, and we carried along with that till 2018, and then we had that pause. And then we started up again seriously in like 2019, 2020. We noticed that there was a difference in our dark sky readings. And it just so happened that 2020 was a record-setting US fire season. And over 10 million acres burned across the US, majority of that in Western states in that year. And that was about 2.3 million more than on the burned of acres, more than the 10-year average, and double that had burned in 2019. And in Utah, it was a really bad year for fires as well. We had a bad season in 2020. And we had, as a matter of fact, 3.5 times more burned in 2020 in Utah than in 2019. So that made problems for us just going around and getting readings for our parks, because we would go out and it would be too hazy or too smoky. Our readings would be diminished. We knew they weren't accurate for what the quality of the dark sky actually was at these places. It wasn't a matter of light pollution. It was something else that was getting in the way. I started thinking, gosh, it's got to be the smoke. It's got to be the wildfire smoke. And many times we went out and were thwarted altogether. So since we have seasonal staffing from like April through October usually, and yet the clearest times are when it's not usually a fire season in the winter, this impacts taking readings and budgeting and staffing, and then the smoke often thwarted our public programs because people want to come out to learn about dark skies, but they want to see those stars. And so this thwarted our public programs. And then we got to 2021. And if you'll advance to the next slide. So 2021 overall in the nation was not as bad of a fire year. However, it was much worse in the West. There were these cataclysmic, as I'm sure you're all aware, these cataclysmic large fires in California and Washington and Oregon. And we actually had a really minuscule fire year in Utah in 2021. We had like only 1/5 of the acreage that burned from the year before, but our skies were still blotted out with smoke because of these massive fires. And this heavily impacted our ability to take readings and to hold these programs again and to even breathe. I mean, it was toxic to breathe, and we couldn't in good conscience hold programs when no one was supposed to be going outside and breathing. And you'll hear Shelby talk about this a little bit later, but she actually for that year tried 7 times to take readings at Rockport and was thwarted nearly every time from getting any kind of clear readings. So if you'll go to the next slide. I just wanted to show a smoke map. This was from August 7th, 2021. We had no active fires at this time, but this red smoke, you can see the red and the yellow smoke is totally covering our state. And that was from those massive fires in California at that time. So next slide. And it just so happened that the Salt Lake Tribune on that day sent their photographer out to Steinecker and Dinosaur out in the Vernal area of Utah because they were going to do this great feature on Utah is ready for its dark sky moment as tourists leave the crowds behind to see the Milky Way. But when their photographer arrived, all this thick blanket of smoke. I mean, we were like the worst air in the world, I think, on that day. And there was this photographer assigned to take these pictures. But now we have a record from those pictures. You can see how much the smoke is impacting looking at the clear skies. Next slide, please. And this is another, later on in the month, those fires still burning in California. We had no active fires. This is a fire map that the New York Times started running every day. And so I just took a screenshot of that particular day. We have no active fires in the state, and yet look at the very dark smoke that is covering our entire state. Go to the next slide. And right around this time, I just did some snapshots of different headlines. Utah is the worst air in the world today, August 6th. Utah's air quality is worsening during drought. The New York Times ran that for September. We're shrouded in smoke. You can't go anywhere within 500 miles. It doesn't matter. It's all smoky. Pollution in the West. You can travel for hundreds of miles and you just won't find any good air quality. Okay, and that was January 8th, 2022. So this is a problem that is not going away for us because we are in a historic drought. I mean, just such a severe drought that has not seen the likes of in 1,200 years. On April 4th, there was a report about measurements that had been taken in the Sierra Mountains, monitoring 265 sites around the Sierras, and the snowpack was only 39% of its average at that time. And so they predicted another cataclysmic fire year for this year. Next slide, please. And here were some the headlines that followed. You could find many, like, dozens of these headlines in news organizations across the United States and actually around the world. But they're calling it a mega drought. It's the worst in 1,200 years. The last time that there was a mega drought, a multi-decade mega drought, was in the 1500s. This drought, it has been going on for 22 years now. We've had a few wet years, but it's mostly been dry during this 22-year cycle so far. And, it's bleak for us. It's really bleak. The fire is just not going to go away. Next slide. And so, I started noticing, oh my gosh, there are fires in December and January in California. This is something new. And then just this last December 30th, Colorado near in Boulder County just blew up in this cataclysmic fire that, driven by 110-mile-an-hour winds, 1,000 homes were burned in just a day. It was insane, crazy. And next slide. So there's never not a fire season now. And so then, as I was preparing for this presentation, just over this last weekend, several states declared states of emergency because of fires. So the Arizona governor declared a state of emergency because of a huge fire there on Thursday. And then Colorado was on an extreme high alert for fire danger over the weekend. And then the New Mexico governor declared the state of emergency for multiple fires on Saturday. Next slide. So here's the thing. Our dark skies regionally, as a region, it doesn't matter if it's local here in this state, regional fire is having an effect on dark skies. So the whole Western United States, also British Columbia, Northern Mexico, it's all affecting our skies. It's all affecting our skies. And so why and how, we need to try to find out why and how is wildfire smoke impacting our dark sky readings? Because in the meetings that I've brought it up in, many people said, but this should be making your dark sky readings darker, but it isn't. So what other factors might be at play? And as the West continues to burn, how will wildfire smoke affect when and even if we can take dark sky readings? And then how will the continual wildfires affect even being able to apply for international dark sky park status in this region? And how will it affect the parks that have designations? And then also, how will wildfires affect astrotourism and our public education outreach, getting the word out about dark skies? Because people want to see those stars, and we've told them that we have the dark skies for them to come see. So this is a problem. And so I'm going to hand it over to Shelby and Paul, who have been doing on the ground readings for us and who have some ideas about why and how wildfires and other particulates and pollutants are affecting our dark skies.
Hello, everybody. My name is Paul Rickets. I work at the U of U in the physics and astronomy department. I'm their interpretation specialist, and I run our observatories. So I also volunteer with the state and national parks, and I've been helping Justina with this dark sky initiative stuff for several years now. So pass it to Shelby and she can take her intro.
Hi, everybody. For those of you who don't know me, I am Shelby Stock. I currently work seasonally for Utah State Parks in dark sky programming and public education. And I assist a dozen parks in all things dark sky related. This includes taking dark sky measurements, conducting education programs, and taking lighting inventories, advising staff on proper lighting choices, and helping to write the dark sky park applications to submit to the International Dark Sky Association. Next slide, please. And so I think the best part of my job is traveling to parks and conducting educational programming. Visitors come from all across the country and all over the world to view the wonderful night skies in Utah. And I've both conducted and attended many outreach events myself. And it's so fantastic to be able to show visitors the Milky Way, the rings of Saturn, a galaxy, or a nebula for the first time. And some of our larger parks can attract upwards of over 200 people at a dark sky event. Next slide, please. Another facet of my job involves taking the sky quality surveys at parks, and this is done both with naked eye observations as well as with objective scientific devices such as the handheld sky quality meter. And I'm sure many of you who work and volunteer in the dark sky world know about these machines, but for those who may not, a sky quality meter is an instrument that quantifies night sky brightness and approximate light pollution levels in a given location. And the values are presented in magnitudes per square arc second, and meaning that even small numerical changes displayed can equate to significant changes in a sky's brightness. And I believe Annie will discuss SQM devices later in her presentation, so I won't go too far into it, but just know that larger numbers indicate darker skies, while lower numbers indicate very light polluted urban skies or daylight. Next slide, please. But as Justina mentioned, we are definitely seeing dramatic effects on the ground because of the intense and prolonged wildfires and accompanying smoke coverage. These next few slides will be for the sciencey folks among us and those who appreciate the numbers and data. And so here at Dead Horse, in 2021, Dead Horse Point near Moab reported their darkest night sky measurements to be 21.91 magnitude per square arc second in the month of April. And that's incredibly dark, almost near the very top of the SQM scale. And just 4 months later, they reported an average reading of 20.34 magnitudes per square arc second, and which, if we were to calculate the brightness of that, that equates to about 6 times brighter skies. And we know there isn't a 6 times increase in light pollution in just 4 months. Next slide, please. And regarding our handheld SQML measurements, scheduling the most opportune times to gather this data is becoming increasingly difficult as well. Not only do we have to now avoid cloudy nights or full moon phases, but we also have to schedule our measurements around lingering wildfire smoke, which is next to impossible in the summer and fall months. And Antelope Island, in this example, they couldn't even attempt sky quality readings beyond March of 2021. In these urban proximate areas, much like Antelope Island is, it seems that sky glow is amplified by wildfire smoke. So we could see that in a dark area, the smoke might attenuate the light and make areas darker, but in these urban proximate areas and the localized light pollution, the smoke is actually scattering that light. Next slide, please. And so that's kind of what recent numbers are telling us, but what are we actually experiencing on the ground is a good question. One example was a program we held last summer in Rockport State Park, and you can see in the image on the left, that is what visitors can typically experience in Rockport on a good night. The image on the right shows what the blanketing smoke did to the skies. This was on August 6th to 2021. There were no active fires in Utah. It was all just lingering prevailing winds and lingering smoke from West Coast wildfires. And there's no doubt that the smoke is diminishing the visitor experience at these parks. Especially if the visitor travels hundreds, sometimes thousands of miles to see these world-renowned skies of Utah, like the image on the left, and instead they are left with the image on the right. And at state parks, we never like to officially cancel programs. We just like to offer alternative programs. We have scorpion walks, owl and bat programs, PowerPoint presentations, virtual stargazing with stellarium, and so on, things that don't have to rely on a starry night sky in the event of clouds or smoke. But we do what we can to make the visitor happy. But is this the same astrotourism experience that guests are expecting? I would say perhaps not. Next slide, please. And okay, and we have begun, in addition to the sky quality readings on the ground, we have been taking more detailed fire maps and detailed photography, and we'll talk about that in a little bit. Next slide, please.
So I guess this is where I jump in. So we have been doing kind of all sky pictures when we going out the last little bit. I was able to find this 4mm lens that fits on mirrorless cameras, and so this image that you guys can see here is taken with that lens, and so you can see that it basically gets the entire sky plus some of the ground, so it's pretty good at letting you see where the extent of the sky look kind of is out there. So it's a pretty good tool at being able to kind of compare different skies to each other. As long as you're keeping all of the settings and stuff on your camera and on the lens similar, then you can get a decent example of what the difference in the skies are. If you want to go to the next slide. So one of the other things that could potentially be causing some of the brighter readings is kind of an uptick in the in the sun's in the sun's activity levels, and so there's a phenomenon called air glow, and in this picture you can see some of that. And basically what's happening is charged particles from the sun are coming into our atmosphere and charging the particles in our atmosphere during the daytime, and then at night they want to relax, and as they're relaxing they give off photons of light. And in this little chart right here you can see that there are several different bands of light that is given off by different oxygen molecules in the atmosphere. And one of the ones that I think are causing the biggest issue here is that green line, the first one, the 557 wavelength. And in the last image, if you want to go back one more for me, real quick. In the last image, you can notice that this entire view of the sky there is kind of lit up, and it's usually not like that. It's usually pretty dark, especially near zenith. But I think this is one of the examples of this air glow. So go forward again. The other example is in this picture where you can see kind of like the waviness of what look like clouds right there, but that's air glow moving along upper atmospheric currents and stuff up right there. So it comes in a few different forms and a few different kind of colors, but this could be causing some of the aspects that we're seeing. If you go to the next slide, you can get an idea of what we're talking about with the solar wind and stuff coming from there. So as there's more activity on the sun, we see a lot more coronal mass ejections, solar flares, and a lot more solar activity streaming higher amounts of particles to our atmosphere. And one paper I was reading says that it's about a half of a magnitude brighter on some of the more active nights. And these take a few days from when we see them escape the sun to when they actually hit the earth and start interacting with the atmosphere. There's not a ton of research that I've been able to find on doing this, but there's been a few, and it seems like what some of the stuff that we're seeing corresponds with what we're seeing with air glow on this. So it could definitely be an aspect of it, but it's not the only aspect from what we're seeing, especially with what we're seeing with smoke. But if you want to go to the next slide. The other aspect of stuff is from the inversion that we see in Salt Lake. And in these two images, they were taken at different dates, but it gives you an idea of the effect of inversion, and also that kind of shows you a little effect of what would happen with smoke too. That on inversion days, yes, we see it as like this really kind of hazy day during the daytime, but at night the inversion likes to settle over the city. I'm assuming smoke kind of acts like that too. So the inversion can like sit in valleys and or not the inversion, but the smoke can kind of sit in valleys and stuff a little bit more. But you see in the picture on the right that the air around the city looks a lot brighter, and there's this kind of like definite cutoff where you see the brightness of the night sky or the lights from the city and how they're being reflected back into back towards the ground on there. And I think that's what's happening with the smoke. And so if we have, you know, a night with all like, or a year with all three of these things going, it makes it a lot harder to determine like the true darkness of all of these areas that we're going. So if it's like cloudy one night, that is difficult, but we can't do anything about that. But if it's smoky and you're in one of these places, it could be giving you high readings. Or if it's a lot brighter due to air glow, giving these reasons of higher readings too. So there's a lot of different factors, and not very many of these have a lot of research that are backing them up or like really showing in what ways they are being or actually affecting everything. So if you want to go to the next one. So this is a decent app to kind of get you an idea of what to use when you're out and recording things. Shelby actually uses this app. I kind of use a little bit different stuff. I use it from different sources, but for normal people, this app is really useful because it gives you all of these parameters, and Shelby can tell you more about it, so she uses it more.
Right, this app is called Astrospheric, and I use different weather apps to determine humidity level and ambient air temperature and things like that. But when you are time limited and you're going out to take SQML readings just on the spot, this is pretty handy. It's just called Astrospheric, and it records the KP index. And so if we are now starting to monitor the solar activity and the solar cycle increasing, we can definitely take note of the KP index on the nights that we go out to take readings. And granted that it does have a little bit of lag from the sun to when it interacts with Earth's atmosphere, but it also does I think Attila Danko has his clear dark sky clock. I think that incorporates that. And so it shows you good seeing conditions, transparency, humidity, ambient temperature, things like that.
Next slide. So here's an example of some of the hardware we're using. So at our other observatory in southern Utah, we have an all sky camera. You can see it moving down here in the bottom right corner. And it takes videos, or not videos, but images every few minutes and stacks them, and we can make these cool little images. But substituting this with the SQM data. So we also have an SQM LU that takes data all night long, every 5 minutes. And so it can actually start giving you a comparison about how bright the sky appears and what the reading from the SQM actually is. And then you can compare those two things directly. And if you can calibrate your camera well enough, then you might be able to figure out, okay, some of the different colors that you're seeing could be from different types of air glow, or it could be if you're seeing the sky darker, but you're seeing fewer clouds, but it's also, or not fewer clouds, but fewer stars, and it's appearing darker in the field of view of this, then the idea that smoke can actually block out some of the light from the stars, making things overall darker. But the other portion of that is if you're nearby in a place where there's a lot of light pollution, or even if you're just like right outside of that, my idea here with this is that the smoke actually reflects a lot of that light back towards the ground, not only directly down, but off, in different directions off to the side. And so it can kind of like flood, it's kind of like a giant floodlight that's just kind of covering a much larger area than where the floodlight actually exists. And that's my idea with how the smoke is affecting like these Wasatch back parks that are seeing brighter skies, even though the smoke in really dark locations should be blocking it. And in some of the pictures we've shown, you can actually see that effect where the sky actually appears brighter in like almost every direction, especially towards the area of light pollution. So, but this is the example of the lens that we actually purchased for this camera. It's actually a really small lens. It's only like this big. And if you're not very careful, you can scratch this dome surface on the front very easily. So you don't want to give this to somebody who's accident prone to dropping it. But there's another way of looking at something similar to this using a method that was, I think it was developed by the National Park System, but there's a person who works for the Night Sounds and I can never remember.
Natural sounds and night science.
Yeah,
night skies.
his name is Brian Bollinger, and some people may have met him before. But he does basically, if you look on the left side, you'll see these three images there. And so you take an image 300 or a stack of images 360 degrees in every direction, and you calibrate your camera in certain ways, and then you're able to determine the brightness of the sky relative to every other direction. And you can actually delete natural background sources like the Milky Way and stuff. So you get just basically an image of what the light pollution looks like in the area. So let's go to the next slide. And so this is an example of some of the hardware we have. We'll start on the right. Oh, actually, we'll start on the left because that shows you the example all put together. This is the box that we put together with Anil Seth and Julia Kamentin. I can't remember how to say her last name. It's like Kamensky from what's that? What's that?
Westminster.
Yeah, Westminster College. And then this is one of their students that helped to deploy this in not goosenecks, the other one, dead horse. So we deployed this down there and had it running for a few months until we were kicked off the roof. But this is just an example of a really basic setup. And so since then we've moved things around and we have this ready to go somewhere else. But on top of the South Physics Observatory, we have another one of these that is basically running off a really cheap $200 little notebook. And you don't need a lot to set one of these up. You can get like a really cheap notebook to be able to do this. It only has like 4 gigabytes and a really basic processor and not very much memory because these just read off into text files. So you can have like years of text files at least, and it would be good. But there's an external enclosure that you can get for the SQM and put everything in there too. So it's not difficult to set these up. Something like this for the how we have it here would probably be around $500 for a setup. But it's something like this that we want to have, like if we want to really be diligent about this and expand this aspect of it and look and see how this is actually affecting stuff. If we have something like this set up in places that as a smoke cloud moves across the United States, we can look at how the sky is getting darker as that smoke cloud is moving, and compare that with like dark locations like in the Great Basin where it's super dark, and if it doesn't affect it, it actually gets darker from there, as opposed to that same smoke cloud moving towards Salt Lake and we're actually seeing brighter skies and stuff like that. That's something that we would want to do just with that. I think I'm forgetting something somewhere and I can't remember what it is. But Shelby, I don't know if you have anything else to add.
Yeah, I just think that speaking for state parks, that's why I think it needs to be a collaborative effort. And that's why I'm glad it's being brought up to the Western Night Skies Council, because there's a multi-state initiative and other resources available, national parks, national monuments, things like that. Because speaking specifically to Utah State Parks, we don't always have the budgetary resources to purchase these permanent SQMLUs. They would obviously be very beneficial to every park in our state, every dark sky park, but many of these parks are very remote. They don't have internet connection. They don't have the infrastructure to be able to house these. And so we're still kind of antiquated in that we go out on foot with these SQML meters, and we don't have that concrete data from when there are fire seasons because we specifically avoid the fire season. And so it would be nice to see the differences, and it would be nice to see that permanent monitoring, but we aren't always capable of that in state parks. So that's why it's good to collaborate with places like the University of Utah or the Western Night Skies Council as a whole, because we all have more resources than just one agency. So.
Yeah, so even if you don't have like a full setup like that, if you go back to the image that shows the was it Atmospheric app? Go right there. So if you can record all of these different things and take a screenshot of one of those smoke maps, at least while you're outside doing stuff, you can get an idea of the smoke conditions and stuff. So if somebody is looking at all of this stuff, they'll be able to at least get some kind of information based off of what the atmospheric conditions are using this. And if there's no smoke, like if you look at the KP index, that might be able to give us a little bit of an idea of like what the sky could be doing as in terms of air glow and other things like that. So it's just better to take more data on this kind of stuff. So if somebody has the interest in doing the research for this, there's like long-term data out a little bit farther out than just them getting started. But that's kind of everything I have, I think. I can't remember what else I needed, but yeah.
Yeah, I think we'll pass the torch to Annie so she has enough time to speak.
There my camera goes. Hi, everyone. My name is Annie, or Anne-Marie Brantley, and I am the interpretive specialist, the dark sky programmer, and the volunteer coordinator for Timpanogos Cave National Monument, which is a unit of the National Park Service. And I completed the designation for Timpanogos Cave National Monument in 2019, and we were declared an urban night sky place. Next slide, please. Thank you. So an urban night sky place essentially means that we're doing our very best to protect our dark skies and teach about our dark skies, but we don't have the same dark skies that you might find at some of the beautiful state parks they've mentioned. Timpanogos Cave is located in American Fork Canyon. That's in Utah County and about a half hour away from 600,000 people. We're a very small park on the edge of some very bright city lighting. As you can see on this slide, we've kind of got a map of the various light pollution, and we're that cute little red square with the pin in it. So we are fighting a lot of light pollution, and we knew that from the beginning. Our numbers have always reflected that. And we recognize again that our skies might not be as dark, but we do a lot to teach about and preserve the night sky that we do have in our park and the surrounding areas. And one of the most successful things that we do to talk about the dark sky are dark sky nights. We collaborate and partner with several different groups who help us with this, including the robotics team from the University of Utah. They bring up their moon or their Mars rovers. There are these robots that these kids or young adults build, and they talk about the surface of the moon and of these planets and what it takes to kind of move on them. And that's always a huge draw into the public. They are always really interested in that. And the other group we partner with is the Utah Valley Astronomy Club. They have, give or take, 15 to 20 astronomers come to every night, and they all bring their telescopes. And we have 200 to 300 people each night look through a telescope for the very first time. And these are people who have never seen the rings of Saturn or even really the moon up close. It's a very magical and life-changing moment for a lot of people. In addition to these star parties or dark sky nights, we do everything else that a other dark sky designation does. Next slide, please. Including, of course, our lighting plan. We did retrofit all of our lights that weren't in compliance, and that gave us the opportunity to talk to a lot of people as that construction and that changeover happened as to why we were making these choices and what was going on. We are quite urban. Our visitation is fairly high for such a small park, and we have the opportunity to talk to so many people about these issues. One thing that we do, both for the IDA as well as for us though, that ties in here most clearly are the sky quality measurements we take. Next slide, please. Oh, that picture did not come out well. Sorry, everybody. We have roughly 1 mile of road that runs through our park. And on that 1 mile, we have 6 different spots that we take sky quality readings or measurements. We submitted our very first report to the IDA last fall, just a couple of months ago. And the first report I sent talked a lot about the smoke and how it wasn't the report I'd been hoping to send and how difficult it had been. And their suggestion was to just read different spots at different nights and different times. But with a park the size of ours, if the sky is smoke filled in one place, it's pretty much going to be smoke filled a mile down the road as well. It makes it very difficult to try to take different readings in different places on different days because the sky is mostly the same throughout our park. Next slide, please. So on clear nights, this is about what cell phone pictures can do. I'm afraid I don't have as amazing cameras as my co-panelists have. So I'm kind of up there at night with my cell phone and with my little SQM reader that I'll talk about in a moment. And I like to snap some photos as I go. On our darkest nights, we see plenty of constellations. We see things lit brightly up. It's beautiful, it's quiet, it's serene. Next slide. And the beautiful photo is what we get on our very best nights. That was taken just a few miles up canyon from us. And then the other photo was taken on a smoke-filled day. As I look at those two, it was more than obvious to me that that smoke was impacting my sky reading. Now that photo was taken during daylight still, but you can see how thick it is and how dense it is. And so as I wrote my report to the IDA, that's mostly what I wrote about. I wrote about how hard it was and how the smoke was impacting. And the answer that I got was, send me your numbers anyway. They're what you have for this year. It shouldn't be that impactful. But it really was. Next slide, please. Now, as a small park, we can't do it all, but we do what we can. Looking at this chart, on the first column, I have the location. The second column are the numbers from summer 2021. It was July 10th for those who care. There was no moon. There were no fires nearby, but there was a lot of smoke. And then the final column was just a few months ago, not months, sorry, weeks ago, April 12th, 2022, not 21. I'm sorry, guys. And you can see that there is a 3-number difference between most of these. And 3 numbers on an 8-point scale is a giant change. And then moving down the locations, you can get to the descriptive words. Like I mentioned, I'm kind of out there on my own with my sky quality meter reader, which is called a unihedron. And I talk to myself a lot. So I have all of these descriptive words from each time that I take these readings. And last summer, most of my words were things like smoky. I don't need a headlamp to see. I can taste the air. And on the positive side, no moon visible. But then just a few weeks ago, the words that I were getting were pristine, cloudless, moderate snow, lots of stars, no moon visible. And the only serious difference between the two was the air quality. For those of you who don't speak air quality, this is a PM 2.5 measurement, and 12 and below is considered healthy. So a few weeks ago, we were at a 5, the air was amazing. Last summer on this particularly difficult night, we were at 61. The air was considered hazardous. So what it comes down to is I didn't see anything else that could be making the difference between my readings. I'm not sure how state parks found my report from the IDA. Perhaps they were just reading all of them and flagged that mine talked about smoke. But I'm so grateful to have been invited to talk here because it's changing the way I do things. It's changing the way that visitors are experiencing what we do. Last summer, we didn't have any dark sky nights due to COVID. As I mentioned, we regularly get 200 to 300 people, and we're in a very small space, so we didn't feel like it was safe or reasonable to gather like that. But this summer, we plan to resume it, and I'm more than a little nervous about what the smoke will do to these beautiful programs. Next slide, please. I see that Shelby reads IDA reports in her spare time. Thanks, Shelby. She mentioned that in the chat. So the only thing that it has so far directly impacted was a student project that we had done with Utah Valley University. We had a group of students who wanted to build little, they're calling them spark beacons on our trail. They're Raspberry Pi devices. And as soon as you get close to this device, your phone can find that network and can tap into the content put there. They really wanted to take pictures of our dark sky and use actual in-place photos for all of these little screens that I've shown below. We were unable to find a single night during their entire semester that would be a clear night that was cloudless, smoke-free, and would result in good photography. They ended up pulling these images off of the web or through their friends. And although their final product is beautiful, it's not quite what they had hoped. It's not our sky with our mountainside. That's mostly what I have prepared for you today. So I guess next slide, and thank you all for coming.
Awesome. Thank you so much, Annie. And if all the other panelists want to hop back on, we have had some good questions coming through the chat. Before we get to the Q&A, we have about 9 minutes, so I'm hoping we'll be able to answer a few questions. I did want to ask all of you just for your takeaway from this panel. You know, we know wildfires aren't going away anytime soon, and they're beyond our control. And what ideas do you have that would help us work together on a regional basis to adjust to this murky future? So Justina, if you wanna answer that first.
Well, what is the question? What can we do on a regional basis? Is that it? Because that is,
yeah,
that
like
is the
what?
Yeah. So this
Yeah,
is
what ideas do you have for us to work together on a regional basis to adjust to this future?
So this is the very first step. As I say, this has been a concern of mine that I've been trying to bring up for 2 years now in every meeting. And I am so grateful to Western Night Skies Council for giving us this venue to put this out. You know, the West is going to burn until there's nothing left to burn. So this is this is why I'm so excited for this discussion. I think coordinating on readings and information is something. Like, if we can have a place to dump all of our information together, if there can be a centralized place that we can share information, that would be a first start, I think. And I'm not sure where that could be housed, but I think that might be the very first place to start, about information sharing site where we can talk about this stuff together. And then I'll let other people respond. I don't want to hog.
Yeah, I guess in a way that's kind of what the Consortium for Dark Sky Studies was invented for, was maybe pulling together all this data and everything for people to use. So I don't know, maybe we have to have a conversation with them and see if that's something that could be housed there or something. Not sure.
Shelby, Annie, anything to add? If not, no worries.
I think it just goes to show that our dark sky stewardship efforts are that much more important, because in places that are urban proximate, where the smoke is seeming to make the sky quality even worse, and the smoke seems to accentuate the sky glow, I think it's even more necessary to have dark sky stewardship and light pollution awareness efforts. So
Awesome. So Travis Longcore put into the Q&A, have you discussed this smoke phenomenon with any of the people who run the large scale light pollution models like Marin Abe? I'm not fluent in dark skies, unfortunately. So but this came in during Paul, during your talk about kind of your conjectures on what this might be meaning and stuff. Have you discussed your thoughts with anyone?
No, I have no idea who those people are that existed before now. So that's part of bringing up this conversation, is to bring awareness and links to other people and sort of resources. So
yeah, he put in the chat, this is the sky quality camera system from Euromix in Slovenia. So interesting thing to maybe follow up on. John Barentine asked, is the state parks doing air quality measurements that could be correlated with night sky brightness measurements, especially anything like LiDAR or ceilometers?
Can you repeat that, because I can't see that?
Is that not showing in your Q&A?
No.
Yeah, I will. It says, is state parks doing any air quality measurements that could be correlated with night sky brightness measurements, especially anything like LiDAR or ceilometers?
We do have our SQM that has run intermittently over the last couple of years. That is basically one building away from the air quality monitor from the university's, what are those people called? Air quality monitor people. Atmospheric sciences. So, you know, if we could pull those data together, and if I could finally get our SQM to run, we had to get a new computer for it because our last one kept dying every 3 months, and I wouldn't find that for a month. So there's big gaps in all of our data, but hopefully with the new one, we'll be able to get continuous data over a longer time and be able to merge those together and do something with that. But yeah, it's something that both Anil Seth and Daniel Mendoza has talked about doing the last few years, is trying to pull those two things together.
And also, you know, state parks, we've talked about we do a lot on a very little, but but some of our co-located national parks do air quality. They do have air quality monitoring systems. So I know the Dinosaur does, and so that's very near where Steinecker is over there, and Red Fleet, which is going for it. And so we could share that information for sure. But we don't have air quality monitors, although we look at other, as you've seen, and John you've now seen what else we measure when we're out there doing that. And thanks to Paul and Shelby for taking that on to do this additional work along with our readings. That's been something they started. And so thanks so much to them. And Anne-Marie did talk about, you guys do monitor air quality. And so, yeah, we would, until we could afford to get our own air quality monitoring stuff, we will lean on our partners that are co-located, which many of our state parks are at national parks too, to kind of correlate that data. And I will bug out in case anybody else wants to say.
Yeah, this will be hopefully the first year we will have data for both dark sky and air quality, hopefully all year long, assuming our equipment holds up and assuming everything works. So we don't have it right now, but we are starting to get that first full year of data.
Awesome. Aubrey Larson asked, if you were to make one recommendation to the IDA about this topic, what would it be?
Be more lenient and understand that not all parks and people have the ability to send somebody out whenever it is clear. And that's kind of the problem with Shelby's position, is that she only works from, I think, what, March to November. And last year, March through November was 100% basically crap readings because of the three different, clouds, smoke, and potentially air glow. And so it's kind of hard to do that outside of the thing. And then some other parks, they have a single manager and like some seasonals that are there even at a shorter time. And so like with what happened to Anne Marie, it's hard to be like, okay, well, all you have to do is pick a different time of year to do this kind of stuff, right? Well, not everybody has the ability just to step out of their house and take SQM readings whenever they want. So some leniency and some understanding from IDA would be amazing at making sure that these parks aren't put in peril for something that's completely out of their control, even despite any efforts and even successes at having darker skies, like less lighting and stuff in their nearby areas.
Yeah, I'm going to jump in because it is so frustrating. We have been bringing this up too in our applications for 2 years now in IDA and saying, hey, smoke is a problem, and just saying, well, change your location or do it on another day. That just shows that, well, that's the reason why I've really wanted to get this conversation started. It's a misunderstanding of how much, how badly, how often, how deeply this is affecting us. And IDA needs to take it. I mean, it's not just light pollution, right? It's these other pollutants too. So these other things also have to be focused on. And sometimes it's in concert together, like in the information that Paul has presented, that smoke can cause this reflective screen that does stuff. But this is affecting even our darkest parks. And so we really need to, it's probably not within the expertise of people that live in humid places to know that places burn this violently and strongly and for so long to understand it. But this is a problem that needs to now be incorporated. And we don't want to lose our designations over forest fires in Canada or California or Washington. That's there's nothing we can do about that. So there needs to be a broadening of scope and understanding of staffing and these environmental problems that aren't just light pollution. So I'll leave it there.
Shelby, Annie, anything to add in the last few moments here? Awesome. Well, that's our time today. We are at 5:01, a little after. So thank you everyone who joined us today. I think this has been a great conversation. We'll send out the remaining Q&A to the panelists, and they can hopefully, they may be able to follow up if they have anything with those of you who asked. This webinar will be available on the Institute of Outdoor Recreation and Tourism's YouTube feed in the next week or so. And we will email that out to everyone who registered for that today as well. So I just want to say thank you one more time to our panelists today. This has been a great conversation, and I hope you all have a great rest of your evening. Take care.